Alright guys, I'm trying to upload the video from yesterday, or no, it's from 2 days ago now, just straight on YouTube, and it says that there's only 2 minutes remaining instead of 2 hours. I don't know why it's different, but I'm hopeful. It's day 2 in Alaska. I can't remember what are we doing today. Hang on, I'll tell you what we're doing today because I'm excited about it. Maybe. It's gonna be awkward, isn't it? Probably, it always is. Okay. See, today's... What is today? Friday? Wow, how did it go so fast? How am I on Friday already? Because Wednesday y'all had a test, and then Tuesday you had a test, then Wednesday was translations, and Thursdays was reflections, and today is Friday, and that's rotations. So today is the big concert that we're up here for, like the whole point of us being here. Hopefully we're getting to see the Northern Lights. We're getting to tour an automotive space at Hutchison and touring Lars. I don't know what that means, but I'm excited for it. Ooh, I really want to see the Northern Lights, y'all. Y'all should text me after class and ask if I've gotten to see the Northern Lights yet so I can be excited and tell you. Okay, so we're going to jump in. We're probably going to go pretty fast because, you know, it's like 8:30. I'm tired. I've been in Alaska for a week. It's time for bed, right? Okay, so rotations, section 4.3 rotations. Our learning objective is to be able to perform rotations and compositions of rotations of figures on a coordinate plane and be able to identify rotational symmetry. So far we have covered 3 of our 4 transformations. Our first was translations, which means to slide things around. Then yesterday we covered reflections, which means to flip things or mirror them. And then today we're doing rotations, which means to turn, right? The wheels on the bus rotate, okay? Go round and round, they rotate. So when a figure is rotated, it is turned about around a fixed point called the center of rotation. We're going to keep life simple. Our center of rotation will always be the origin. Okay? Our center of rotation will always be the origin. And the amount that it is turned is called the angle of rotation. So if you look at one of the 3 clocks in the room, all 3 hands, the second, minute, and hour hand, they turn from a single point. That point is called the center of rotation. So in this case, it's turning, you got these little flags that are turning around point P. Okay, so this flag turns and becomes this flag. And the amount that it turns is called the angle of rotation. So if Q turns to Q prime, if I draw a line connecting Q to P and Q prime to P, that angle right there is 40 degrees. So 40 degrees is the center of rotation. Okay. So if you look at the minute hands, if you think of, for example, the hour hand pointing at 12, and if the minute, the hour hand's pointing at 12, if just the minute hand rotated from 12 and was now pointing at the 3, well, it turned 90 degrees. Okay? It created that 90-degree angle. So if you look at the clocks up on the top right, we have our normal clock that goes tick, tick, tick this way. And then we have our wonderful, awesome counter clock that goes the opposite way, okay? So when we talk about rotation, we are talking, or directions of rotation, we talk about clockwise and counterclockwise. So the word counter means opposite, or the prefix counter. So this is the opposite of clockwise. And I want you to take a moment, turn and talk to your neighbor. Why do you think we use clockwise and counterclockwise instead of left and right? Right? Take like 12 seconds. Okay? So think about it. If I said turn the clock to the, or turn your thing to the right, well, are the clock hands tick to the right? If you're looking at the clock, top of the clock, sure, they're ticking to the right. But when you look at the bottom of the clock, they're ticking to the left. Same with up and down. On the left of the clock, they're ticking up, and on the right of the clock, they're ticking down. So we can't use right and left and up and down when we're talking about directions for rotations, because it changes based on what part of the figure you're looking at. All right, so we use clockwise and counterclockwise to talk about which direction is it ticking. And a 360 degree rotation, if I rotate something 360 degrees, that's a circle, right? So if I say rotate 0 degrees, don't move at all, rotate 360 degrees, you end up back where you started. So we don't really look at 360 degree rotations because essentially you're not moving, you're just staying where you started. All right, flip on over. Okay, so we are going to be looking at 3 turns. So figures can be rotated any angles. You could rotate it 129 degrees, 47 degrees, but we're going to focus on 3. 90 degrees, 180 degrees, and 270 degrees. Notice those are all multiples of 90. Okay, so typically when I teach rotations, I am here and I teach it actually using the projector and use the physical paper because it's actually easier to physically turn your papers to see this. But if I were to take triangle ABC and turn my paper 90 degrees clockwise, okay, I can't rotate on the iPad, I'm sorry, but if I were to turn my paper 90 degrees clockwise, this is what I would see. I would see what looks like triangle A prime, B prime, C prime. So that's why off to the right, you see 90 degrees equals 1 turn, 180 equals 2 turns, 270 equals 3 turns. So if I physically turn my paper 1 turn around, 2 turns around, 3 turns around, where like 1 turn would be the top is now on the side, 2 turns is the top is now on the bottom. Then you're going to see these various figures, okay? And we talk about a 90 degree turn because so remember we said the origin is our center of rotation, right here, this is our center of rotation. So if I were to draw a line connecting A to the center of rotation, the origin, and then A prime to the center of rotation, that's a right angle right there. Same thing with B and C. Okay? If I connect C to the center of rotation and C prime, that's going to get crowded, so I shouldn't do that. But those would also be a 90 degree angle. So for two turns, 180, if I connected A to the center of rotation and then I connect a double prime, so 2 turns, well, look at that. That creates a straight line which measures 180, okay? So that's where those degrees come from. And that would be the same is true for B to B prime, a straight line through the origin, C to C prime, or double prime, excuse me. So notice, because this is, I'm not lazy, I'm efficient. Anytime you see CW, that stands for clockwise, CCW, counterclockwise, okay? So most of the time it's going to tell you which direction to go, clockwise or counterclockwise. If it doesn't tell you, go counterclockwise. So counterclockwise is the default direction. So if it doesn't tell you which way you're rotating, go clockwise. Go counterclockwise, okay? So you look up at the backwards clock that says counterclock in yellow. That's the direction that you're going, okay? So the rotation rules here to remember, we talked about, we had XY maps to X plus A, Y plus B for the translation rule. We had we had 4 reflection rules for reflecting over the x-axis, the y-axis, y equals x and y equals negative x. So the rule, we have more rules, which are, again, just memory shortcuts. Don't try to memorize them. Write them down if you're using them. But these are based on rotating counterclockwise. Rotating counterclockwise. However, what I want you to notice, so 270 degrees is 3 turns. So if I take triangle ABC and I rotate it 270 degrees clockwise, go 1, 2, 3 turns counterclockwise, that is the same shape that I get when I go, or 3 turns clockwise is the same thing as 1 turn counterclockwise, okay? So 90 degrees counterclockwise is the same thing as 270 degrees clockwise. And 270 degrees counterclockwise is the same thing as 90 degrees clockwise. All right, 3 turns in one direction is the same thing as 1 turn in the other direction. Okay. All right, and then to physically turn the paper, which I would normally show this, but you're just going to have to kind of use your imagination or try it out. Don't use your imagination, just try it with your paper. Physically turn the paper according to the rotation. Pretend the axes are now in their correct orientation. Write down the new coordinates of each point. Turn the paper back upright, and then plot these new prime points. And I will definitely show you guys this on Monday. Please remind me, because I think that it is valuable to see it. We're going to focus, however, on using the rotation rules, because I can't rotate the iPad in a way that you guys could see. I can physically turn it upside down, but the image does not rotate. The image stays up straight up. Okay, so example 1, graph triangle ABC with vertices A at 3, 1. A at 3, 1. Always plot, or always label your points. B at 3, 4. And C at 1, 1. Connect your points to make your triangle. Hope you guys can see that, because I just really like this color. And its image after a 180 degree rotation about the origin. So I just copied it down. So notice I didn't write any alternative for 180 degrees, because turning your paper upside down to the left, turning your paper upside down to the right, it's the same thing, right? 2 turns clockwise, 2 turns counterclockwise, it's the same thing. So 180 degrees in either direction is going to end up in the same location. Okay. So the rotation rule for rotating 180 degrees, xy maps to negative x, negative y. It just negates. So let's look at this point by point. Okay. So A was at 3, 1. Now A prime is at negative 3, negative 1. Note real fast, if these were negative, they would become positive. So that negative x, if this was a negative 3 that I was plugging in, negative negative x would be positive x. Okay, so A prime is going to be at negative 3, negative 1. And that's A prime. B was at 3, 4. Well, the rule says xy maps to negative x, negative y. So negative 3, negative 4. Negate each coordinate. Negative 3, negative 4 is B prime. And then C at 1, 1. Negate those so that C prime is at negative 1, negative 1. Okay? Label the point. C prime, connect your dots. I'm gonna make that extra thick because I think I chose the same color as the grid. So I'm gonna make that a little thicker than normal. Okay. All right, so triangle A prime, B prime, C prime has been rotated, or ABC has been rotated 180 degrees about the origin to make triangle A prime, B prime, C prime. All right, you guys try graphing quadrilateral RSTU. And we're gonna skip the second example for today. So just go ahead and finish up the you try. Hey Siri, set a timer for 2 minutes.
Okay, your timer is set for 2 minutes.
All right, keep working, guys. I'm just gonna go ahead and plot RSTU because I know you guys can do that. Oh, jeez. It scares me every time. Okay. So you're plotting RSTU, and then you're going to rotate it 270 degrees counterclockwise about the origin. So 3, 1, 2, 3 turns. So it's going to be over here. Okay. Well, it's going to be over here more like, but so 3 turns counterclockwise about the origin. All right, so the rule for rotating 270 degrees counterclockwise is xy maps to y negative x. So if r is at 3, 1, and y negative x, that means you're going to swap the coordinates and only negate the x coordinate. Okay, so r prime, so you're going to swap them. So 3, 1, so this is x, y, remember. Y now comes first, so 1, negative 3. Swap them, only negate the y. Okay, so when I plot r prime, it's going to be at 1, negative 3. Be r prime. Okay, same thing for s. S is at 5, 1. So to get to s prime, swap them. So 1 is now first, and 5 is now negative. So 1, negative 5. Okay, and that will be s prime. And then t. So t is at 5, negative 3. So for t prime, that y now comes first. It stays negative. We don't mess with the sign of the y. And 5 is now negative 5. So negative 3, negative 5 for t prime. And notice, like, when you're in the middle of doing these, they can look, it sometimes feels like you're doing it wrong. Keep going, though. Keep going. The last one, u, is at 2, negative 1. So u prime, you're going to put the negative 1 first and negate the 2. Negate that x. So 2, negative 1 becomes negative 1, negative 2. That's u prime. Now we're going to connect our points. And you can see our, let's call it a kite, has been rotated 3 full turns around the origin, or 1 turn clockwise if you were thinking of it in that direction. Okay. So let's skip. I will pause it there. I'm not going to move it away just yet, but we're going to skip the rotating with the rule rotating by turning until Monday, and I will go over that with you. But you can do your homework with your notes or with the rule. It's not bad. In fact, a lot of folks like it better. So on your homework, okay, so on the first side of the puzzle time, it's just, the first one is vocab, the second is filling in the rules for the 3 rotations. The second, it doesn't give you a direction. For E, F, and G, it says to rotate it 270 degrees about the origin. If it doesn't state a direction, remember which direction you go? Counterclockwise. So you can use a rule for that. You don't have to graph it. You can graph it if you want to, but you don't have to. So you're going to plug A, B, and C into the rule for rotating 270 degrees counterclockwise, and it will pop out A prime, B prime, C prime. Okay? And then on the back side, yeah, there's a back. It's rotating those 6 figures about the origin. Notice on 100 when it tells you to rotate. Gracious, I accidentally included 4 180 degree rotations. So on 180 degrees, it doesn't tell you which direction to go because it doesn't matter, right? To turn, turning something upside down is upside down. Doesn't matter which direction you go. All right, that will be due on Monday. We will go over it in class like normal. You should have hopefully plenty of time to get your homework done. I don't know how long this video has been going, but it feels short. I will actually see you guys on Monday. I'm excited, and I will probably have lots of pictures and all kinds of things like that to show you. So I will see you soon. Make good choices, be kind, have a good weekend. Make sure that you continue for the last few minutes of class, be respectful, clean up after yourselves. If there's trash on the floor, please take a moment or two to pick it up, especially my fourth period. Mauricio, if you're here, I would like to put you in charge of facilitating the cleanup. Make sure that my room is left nice and tidy, and I'd really appreciate it. All right, I will see you guys soon. Make good choices, be kind.